Hello friends, in this video we are going to discuss about one of the important modulation technique in analog modulation is nothing but angle modulation. Here angle modulation means it is the combination of two modulation techniques. First one is phase modulation and second one is frequency modulation. The phase and frequency modulations are combinedly called as analog modulation. First, let's see what is phase modulation. Phase modulation occurs when the instantaneous phase varied in proportion that of the message signal. In phase modulation, we know in order to perform the modulation, we need carrier signal as well as message signal. Here, the phase of the carrier is instantaneously changing in according with the amplitude of the message signal, that is known as phase modulation. Now in order to perform the phase modulation we need instantaneous phase value. Okay, instantaneous phase value, that is phi of t. Phi of t is nothing but instantaneous phase value. This is phi of t. Phi of t is nothing but instantaneous phase value equal to kp into m of t, where kp is the phase sensitivity of the modulator and m of t is the message signal. Okay, in order to perform phase modulation we need carrier and message signal, and here the phase of the carrier is instantaneously varying with respect to the amplitude of the message signal. That's why we need to know what is the instantaneous phase of the carrier signal. The formula for finding the instantaneous phase is phi of t is equal to kp into m of t, where kp is the phase sensitivity of the modulator and m of t is the message signal. And resulting PM wave, we know in generally our carrier signal is like this: C of t is equal to Vc cos omega ct. Okay, Vc cos omega ct is our carrier signal. Here we need to add our phase shift to our carrier signal. Okay, here observe S of t is equal to Vc cos of omega ct plus kp into m of t. This is the resulting phase modulated wave. Here Vc is the amplitude of the carrier signal. Here Vc is the amplitude of the carrier signal and cos of omega ct is the frequency of the carrier signal and kp into m of t is the instantaneous phase value. This means this carrier is changing instantaneously with respect to message signal amplitude. The phase of the carrier is changing instantaneously with respect to message signal. Observe, this one is the modulated waveform or modulated mathematical representation for phase modulation. Now coming to frequency modulation. The second one is frequency modulation. Frequency modulation occurs when the instantaneous frequency is varied linearly with the message signal. In case of phase modulation, the instantaneous phase is varied, but in frequency modulation, the instantaneous frequency of the carrier signal is varying in according with the message signal amplitude. Okay, here we need to find the instantaneous frequency. In the case of phase modulation, we find the instantaneous phase, but here we need to find the instantaneous frequency, that is omega I of t. Omega I means instantaneous frequency is equal to omega c plus 2 pi kf into m of t. Here observe omega c plus 2 pi kf into m of t, where omega c is the frequency of the carrier signal and kf is the frequency sensitivity of the modulator and m of t is the message signal. Okay, this is the mathematical equation for instantaneous frequency. Now coming to theta of t. Theta of t nothing but how much angle it is changing. This frequency modulation is come under the angle modulation. Here theta is nothing but angle. The angle equal to integral 0 to t omega I of t. Omega I of t is nothing but instantaneous frequency. Now integrate this omega I of t with respect to t, then we get omega ct plus 2 pi kf integral 0 to t m of t dt. This is our theta of t. Now simply substitute theta of t in FM wave. In FM wave we have S of t is equal to Vc cos omega ct plus theta of t. Here instead of this we have initially theta of t, but when we substitute theta of t value here, then we can get like this: omega ct 2 pi f 2 pi kf integral 0 to t m of t dt. Okay, this is the resultant frequency modulated wave. This is the resultant frequency modulated wave. Observe here, both frequency modulated wave and phase modulated wave, both phase modulated wave and frequency modulated wave are somewhat similar. Here only one difference is, here message signal there is no integration before the message signal, but in case of frequency modulation we have integration before the modulating signal. That means if we modulate the integrated message signal, we can get frequency modulation. If we modulate the differentiated message signal, then we can get phase modulation. Now coming to how can we find, see here, generation of PM from FM from PM and vice versa. How we can generate FM modulated wave by using PM modulator, and how we can generate PM modulated wave by using FM modulator. Here we will discuss about that. Okay, now first consider generation of FM using phase modulator. Here we are using phase modulator, but we are generating FM. How we can generate means, we know in FM, here observe second equation, in FM modulated wave we have integrated message signal. That means we need to add the integrated message signal to the phase modulator in order to get the frequency modulation. Here observe, we are adding integrator. This is the integrator. Integrator is to the message signal, then we will get integrated of the message signal. That integrated message signal is applied to the phase modulator, and another input applied to the carrier, then we will get frequency modulated signal. Okay, in order to get frequency modulated signal from phase modulator, we simply integrate the message signal and apply to the phase modulator signal, then we can get frequency modulated waveform at the output. Okay, now coming to the generation of PM using frequency modulator. In order to perform the PM is nothing but frequency modulated wave, we need to differentiate our message signal, because in frequency modulator we are integrating our message signal, but in case of generating phase modulator from the frequency modulation, we need to use differentiator. Here we are applying our input message signal to the differentiator, and the output of the differentiator is nothing but differentiated message signal that is applied to the frequency modulator, and another input is carrier signal. These two inputs are applied to the frequency modulator, then we will get phase modulated signal. This is how we can generate frequency phase modulator by using FM waves by using phase modulator, and PM waves by using frequency modulator. I think you understood this topic. Thank you for watching this video.